Welcome to this explainer. Right now, there's a massive, planet-sized mystery unfolding literally right beneath the waves. Our oceans are going through this profound, unprecedented transformation, and honestly, the data we got back in 2025 left scientists absolutely stunned. So, we're going to break down exactly what happened, why the numbers seem to be completely contradicting themselves, and finally, look at some mind-blowing, cutting-edge tech that's letting us monitor all of this in real time. Let's get into it. Okay, let's dive into this. 20.80 degrees Celsius. Now, you might be thinking, it's just a number, right? Well, in the context of modern climate data, this figure is an absolute game changer. It officially marks 2025 as the third warmest year for our oceans since we started keeping these records back in 1993, just barely sitting behind the blistering highs of 2023 and 2024. But here's the kicker. It's not actually the temperature itself that's so shocking. It's the specific global conditions that were happening when we recorded this temperature. That's what makes this so fascinating. And that brings us to the core paradox of this whole explainer. You see, 2025 saw the start of a La Niña phase. And if you follow climate patterns at all, you know La Niña is the cold phase of the El Niño Southern Oscillation. It's famous for these cooler-than-average sea surface temperatures in the central equatorial Pacific, which normally acts like a giant air conditioner for the whole globe. So, here is the burning question. If La Niña is this natural cooling event, why on Earth was 2025 one of the hottest ocean years we've ever seen? Like, no joke, it was actually the warmest La Niña year ever recorded. How does that make sense?
Now, what's really interesting about this slide is how perfectly it shows the problem. Look at this global sea surface temperature chart tracking the last 30 years. The red bars, those are your warming El Niño phases, and the blue bars, those are the cooling La Niña phases. But look really closely at that white line, which is the average temperature. Notice how, especially in these recent years, that white line just keeps aggressively climbing, even when it cuts right through those wide blue bands of La Niña. It's like the Earth's natural cooling system kicked in, but the temperatures just ignored it and kept rising anyway.
So what's the answer? Well, the resolution to this paradox is pretty stark, but it is absolutely crucial that we understand it. Basically, the underlying long-term warming driven by human-induced climate change has gotten so incredibly powerful that it's literally overriding the natural cooling influence of La Niña. The baseline has completely shifted. According to Mercator Ocean International, a staggering 81% of the global ocean saw above-average sea surface temperatures in 2025. All that human-driven heat accumulating in our atmosphere, it's fundamentally rewriting the baseline for our waters. To put it simply, the natural cooling phases of today are actually warmer than the warming phases from just a couple of decades ago. Crazy, right?
And when we break down these global surface records, we start to see a much clearer picture of the macro-level reality. This wasn't just some weird, localized fluke. Globally, like we said, we hit 20.80 degrees Celsius, the third warmest ever. But look at the regional extremes here. The North Atlantic averaged 22.44 degrees. That makes it the sixth warmest year there in over 3 decades. And the Mediterranean Sea? It reached a sweltering 21.21 degrees. That's its second warmest year on record, with 98% of the entire basin sitting above average temperatures.
But, surface temperatures really only tell a fraction of the story. If we want to truly grasp what's happening with climate change, we've got to look deeper. Karina von Schuckman, who's a senior advisor over at Mercator Ocean International, pointed out something super important. She noted that in 2025, ocean heat content, which is a measure of the total amount of heat stored in the ocean, reached its highest level on record. So even if the surface shows a slight, temporary dip in temp, the upper 2,000 meters of the ocean are acting like a massive sponge, just constantly soaking up and storing that heat. Actually, this deep ocean heat content is one of the absolute most robust, undeniable indicators we have of long-term global warming.
99.6%. Let's just pause for a second and let the sheer scale of that number sink in. Because what that represents is an almost unimaginable level of ecological stress. That near-perfect percentage? That represents the portion of the Mediterranean Sea that got hit by extreme marine heat waves over the course of 2025. Essentially, the entire Mediterranean basin was just engulfed by these intense, prolonged periods of freakishly high ocean temperatures. I mean, in the month of June alone, a record-breaking 64% of the Mediterranean was dealing with these heat waves at the exact same time. We're not just talking about nicely warmed bathwater here. These are extreme thermal events that literally devastate marine ecosystems, totally disrupt weather patterns, and put coastal economies in serious jeopardy.
And this brilliantly illustrates exactly what we're talking about. This deviation heat map tracks Mediterranean temperatures from 1993 all the way to 2025. Over on the left, back in the 90s, we see those cool, comforting blues, which means below normal temperatures. But as your eyes sweep over to the right toward the present day, wow, the blues completely disappear. They're entirely replaced by this unbroken wall of deep, alarming red. It's an incredibly stark visualization of an ecosystem that is just rapidly, constantly heating up, year after year, with absolutely no break.
Now let's jump over to the North Atlantic, because the situation there is just as dramatic. In 2025, 97% of the North Atlantic basin was impacted by marine heat waves. And maybe even more concerning, 63% of the region went through what scientists classify as intense events, so strong, severe, or extreme heat waves. We saw record-breaking annual mean temperatures in the Gulf of Mexico, the Bay of Biscay, and all around the British Isles. As oceanographer Simon Van Gennep pointed out, these prolonged, super-warm events have hit totally unprecedented levels. They are massively heightening the immediate risk to marine life and coastal habitats all along Europe's shores.
Meanwhile, at the very edges of our world, the poles are basically acting as our planetary fire alarms. Both the Arctic and the Antarctic are going through these rapid, profound, and ongoing changes. In the Arctic, winter sea ice formed way later than usual because surface temperatures were running more than 2 degrees above average. That led to a record low sea ice extent in December. And down in the Antarctic, same story, different hemisphere. Sea ice formation was super delayed and stayed well below average for almost the entire winter, from June straight through to October. To put that into perspective, for 11 out of the 12 months in 2025, global sea ice extents ranked right in the top 5 lowest ever recorded. Honestly, I think this quote from oceanographer Romain Bourdelle-Beatty perfectly sums up the severity of all this data we've just unpacked. He says, what was considered warm 10 years ago has effectively become the new cool in today's climate baseline. Think about that for a second. We aren't waiting for climate change to happen someday in the future. We are actively measuring it right now, in real time. Our entire frame of reference has totally shifted. So the crucial point is this. Why does all this actually matter to you and me? Well, the stakes literally could not be higher. The oceans cover more than 70% of the Earth's surface. They're basically the lungs of our planet, generating roughly 50% of the oxygen we breathe. They're also our main climate buffer, absorbing about 25% of all atmospheric carbon dioxide. Our survival is 100% tied to the health of our oceans. Yet, and this is the wild part, despite doing all this heavy lifting to keep us alive, more than 90% of our oceans remain completely unexplored. We are essentially flying blind in the most important ecosystem on Earth. But the good news is, technology is finally catching up to the challenge. If we're going to understand and protect the oceans, we desperately need eyes and ears beneath the waves. Enter the Internet of Underwater Things, or the IoUT for short. This is a genuinely transformative, cutting-edge ecosystem made up of interconnected underwater devices, sensors, and autonomous vehicles. You know how the regular Internet of Things connects your smart home gadgets? Well, the IoUT is doing that for the ocean floor. It networks the ocean, collecting, transmitting, and analyzing marine data in real time. This is the exact technological breakthrough we need to finally let scientists monitor that vast, unexplored 90% of our waters. So, how does an underwater Wi-Fi network actually work? It basically breaks down into 3 brilliant steps. First up, you have wireless sensor networks. These are battery-powered smart sensors deployed all across the ocean to collect vital data on things like temperature, acidity, and currents. Second, since your average home Wi-Fi router definitely won't survive a quick dip in the ocean, the system uses acoustic communications. Yep, it literally uses sound waves to transmit these findings across huge aquatic distances. And finally, step 3. Advanced artificial intelligence swoops in to process this massive influx of data. The AI analyzes everything, giving us real-time monitoring of the exact climate shifts and marine heat waves we've been talking about today. It essentially takes all that raw data and magically turns it into actionable intelligence.
We've seen exactly how human activity has fundamentally altered the thermal baseline of our oceans, literally overpowering natural systems like La Niña. But for the very first time in human history, technologies like the IoT are handing us the tools we need to map, understand, and hopefully protect these unseen depths. We are standing right on the brink of a totally new era of oceanic discovery. So I want to leave you with this one thought. With 90% of our oceans still totally unexplored, and this incredibly smart network finally shining a light into the deep, what will the Internet of Underwater Things reveal next?